Okay, so today we're talking about probing, using a mirror, and using a sludge judge. So, with probing, we use these hand probes here, and the goal is to find and evaluate objects underground. And typically, once we find something, we're trying to mark the edge of it, so that we're trying to identify and mark the edge of it, so that we can understand if it's a tank, is it round, is it rectangular, what direction is it pointing, if it's a drain field, how big is it, what type is it one single bed, is it trenches, that type of thing. So basically, we use the hand probe. We just go around and we usually have an idea where we want to start. And maybe there's a white pipe or some depression or some indication like, hey, we think something's here. So then we just, poke into the ground until we hit something. And then if it feels like what we're looking for, we can work our way out until we hit an edge. So we can say, we hit it, missed it, and then mark that with the flag. And then maybe go a few feet away, hit it, missed it, and mark that with the flag. And then as you start working your way around, whether it's a tank or a drain field, you start delineating the edges and then start understanding what that component is. The reasons why you might want to probe for a septic tank, obviously number one is to locate the tank. And then another reason is because you need to identify where, so on top of a tank, there's openings in a tank. And typically in a septic tank, there's inspection ports, which are usually smaller, 4 or 6 inch. And then there's main accesses, which is usually the main 24-inch manhole to get into the tank, which is usually over the center of either the tank itself or of the compartments. And typically on a round tank, the main access is in the middle, and the inlet baffle inspection port, we call that the inlet baffle inspection port. That's over the inlet where the pipe from the house comes in. And there's typically, on the opposite side of that, a outlet baffle inspection port where the pipe leaves and goes to the next drain field or next tank. So some details on tanks. There's rectangular tanks and round tanks. So for a rectangular tank, prior to 1997, most tanks were single compartment tanks. So you had a house, one single compartment septic tank, and then a drain field or something beyond. After 1997, they started requiring either 2 tanks or a 1-2 compartment tank. And so when you're working on tanks, it's important to know, if there's 2, which one's the first, which one's the second. If it's 1 tank with 2 compartments, then you want to know if you have to dig down to the main lid, the main access manhole, you want to have an idea where that is positioned in relation to the top. Because if you're digging 12 inches, 24 inches by hand, you don't want to waste your time, So, there's certain kinds of tanks. There's some of the rectangular single compartment tanks are referred to as Sartan tanks. That's the name of the manufacturer. And on those tanks, the main accesses, there's one over the inlet and one over the outlet. Other single compartment tanks, if it's round, like I said, the main axis is usually in the middle, and the inlet and outlet baffle inspection ports are on opposite ends, opposite each other. And one way, when you're digging and you're not sure where the main access is, you can kind of find the center and just dig down and then start working your way towards the front of the tank, and eventually you'll find an edge. And then you can see, which way the curve of the lid goes, and just follow that around and uncover the main access. If it's a 2 compartment tank, so if it's built after 1997, if it's a 2 compartment tank, the main access for the first compartment is usually over the center of the first compartment, and the main access of the second compartment is closer to the back of the tank. So there'd be two accesses for one tank in a two-compartment tank situation. So then another common thing we look for with probes besides the septic tank is the absorption system. And the first reason why you're probing in an absorption system is obviously to locate it. And sometimes that's easy, sometimes it's hard. But we have some other training on that. But the second reason to probe an absorption system is to evaluate its condition. And we evaluate the condition of an absorption system by measuring the amount of dry stone or dry aggregate that's in the absorption system. So, if typically let's say there's 12 inches of stone in an absorption system, we want to know how much of that stone is dry. So once you identify the edges, then you can kind of go to the center. You can make like a test hole, and you can use like an inch bar to make a bigger test hole, and then you can use your probe like a dipstick, and you dry it off. You go down through the stone to the bottom, spin it a couple times, bring it up, and measure the amount of water, and then subtract that from the total height of the stone, and it tells you how much dry stone is in there. So that's and there's standards. There's criteria for how much dry aggregate is acceptable. Okay, so the next tool that we use pretty often is a mirror. So it's a mirror on a pole, and usually have a flashlight in your other hand. And once we identify the tank and uncover the main access, then we use the mirror and flashlight to look for structural integrity of the top of the tank, for baffles, make sure the baffles are intact. So that's something that you just kind of learn from experience, but that's how we inspect the interior of tanks. Over time, there's things you can learn about these different components. The baffles of tanks, which we learned about in the previous lesson, if they're concrete, they can deteriorate above the water line, down to the water line. So the gases in the wastewater eat the concrete and they deteriorate down to the water line. And typically the outlet baffle is the one that deteriorates first, but sometimes the inlet baffle either falls off, gets knocked off, we need to make sure the baffles are there. Plastic baffles, which are now what everybody's typically using, the thing that happens with them is that they can become unattached from the wall. They're plastic sheets and they're anchored into the wall, and sometimes one of the sides becomes unattached, so then they're not as effective. So we need to look for that. And so baffles that are missing or deteriorated are not satisfactory, something that needs to be addressed. Another thing we inspect with the mirror is the structural integrity. So we look for rusted rebar, exposed. So pretty common on the ceiling of the tank. So when you look down there at the mirror, you look down, put the mirror right at the liquid level, and then you're looking, with the mirror, you're looking up. You're looking at the ceiling of the tank. And if you see any rusted rebar, exposed rusted rebar in the ceiling, that's unsatisfactory and needs to be repaired. So that shows up usually with, you see the red rusted metal, coming through the concrete, and then that's something that needs to be repaired. Obviously cracks, if the top is cracked, that's definitely unsatisfactory. That needs to be, the top needs to be replaced. And also if the concrete's deteriorated, so if it's flaking off, there's some situations where the concrete gets chemically deteriorated. There's a white film on it, and it's just kind of pulling away and falling in. That's unsatisfactory, and there needs to be further investigation to determine if it can be repaired or if a tank needs to be replaced. And then the final thing that we do to inspect the tank is we use the sludge judge. So typically just a clear tube with a check valve on the bottom, push it down into the tank. When you pull it up, the check valve closes, and you're able to see the sludge level in there. And if the sludge level in the tank is around, if it exceeds 20% of the capacity, then it's unsatisfactory and it needs to be pumped. So, so if the liquid level is 50 inches and the sludge is 5 inches, then you do the math with the calculator, and that's below 20%. If it's 50 inches liquid level and there's 12 inches of sludge, then it needs to be pumped because it's more than 20%. And with the solids, we add the bottom solids, the sludge, to the scum on the top. Add that together. So if it's 12 inches on the bottom and 2 inches on the top, you would call that 14 inches of solids, and then you do the math as far as what that is a percent of the total height. So that's how we use the sludge judge. So those are the three main tools I wanted to talk about today. So thanks for watching.